Hello, everybody. My name is Anja Ehrenfried. I'm the managing director of our company, City Thinking. City Thinking is an international company. We have our headquarters in Spain, and we're also counting with a representative office in Moscow. Over the last 10 years, our company had been concentrating in finding an answer how to design and manage new city extension related to the big demand of affordable housing in the coming years in the emerging countries. In order to do so, we bring together research and cutting-edge technology into new ways of designing cities. We work for a digital transformation in the construction industry of the new urban area. This means when we try to go away from the traditional way of construction to an industrial approach and off-site production. We also are concentrating in order to control the whole design and managing process from all the different scales of this project. This means starting from the territory till the kitchen. This is an integral, global approach, which helps us not only to cut time and cost significantly, but also to involve all the different stakeholders at the same time. So we all know the challenge to tackle in the next 35 years is that the urban population will increase by 1.5 billion people. This will mean that in the coming decade, $5 billion will be invested in the construction of the new residential districts. Nowadays, this management presents one of the biggest opportunities for the social, ecological, and economical development of our planet. In order to tackle this challenge, we have to take into consideration multiple factors: economic ones, ecological ones, social ones, functional ones, in order to control them at the same time. By today, the current urban design processes are facing clearly difficulties in coping with this environmental pressure and this growth. In this way, it's very, very important to rethink the urban development patterns. We always say in this way, it's very important to go for a scientific approach. The traditional way of doing city extension or urban planning is not furthermore able to cope with this new area. On the other hand, and in order to narrow the affordability gap, because this new city extension is always related to a big demand of affordable housing, we have to take into consideration the four following points, which I can show you here in this graphic. So there are like 4 points which are very important to take into consideration by doing affordable housing projects in emerging countries and everywhere around the world. One point is the land. It's important to look for the right position, to have a good connection to the existing city or to the existing city extensions in order also to lower the cost for infrastructure. Then a second point is the development. The development is what I was saying before. Development is important to think about how you can reduce the cost of developing those houses. Important thing is to have a critical mass. In order, if you work with a critical mass, you can apply an industrial approach. And this industrial approach will help you to control the time and the cost of your project significantly. As we said before, this helps you to go back from go away from the traditional way of constructing to an industrial approach and an off-site production. How can you do this? This is one thing. This is a project I show you here, where you can see like the different steps we have to take into consideration. There is a step from the territory to the kitchen. So based when we start with the first sketches, how to think about these new urban extensions, we already have to take into consideration what will be the final product. In order to improve or to optimize this industrial approach, we have to work with a standardization process and a modular approach in all scales and in every construction stage. Things have to fit together. So from the master plan to the final layout of the houses is like one goal, one design process. This also helps us in the future to be very flexible and adaptable to future market changes. What does this mean? I mean, these type of projects normally are not being developed in 5 years. If we talk about city extensions of 100 hectare, 200 hectare, we are talking about 15, 20,000 units. So when we start with the first stage, the market is prepared for a certain product. But when we finalize, like the last stage of the project, the market certainly had been changed. This new approach to working with a modular and a standardization process will help us to adapt fastly to the changing market conditions. Because I can interchange different models and receive a different product mix, a different product to set on the market based on the same models I already designed at the very beginning. So this is not only very efficient, but also very flexible. And as said before, we will need to find an answer how these new cities has to look like. This is why we used to apply when we work in these kind of projects with a principle of ecosystemic urbanism. This is a system which had been developed by BCN Ecology in Barcelona. This is working with different KPIs, social KPIs, functional KPIs, ecological and economical KPIs. And like the 4 pillars, this economic system is based on, or this urban system is based on, is like the compact, the city has to be compact according to its morphology, less land consumption, less distances from one place to the other one. The city has to be complex in order to its organization. Now, no sleeping cities where nobody can work, where you cannot shopping. It has to be complex in order to fulfill the day-by-day needs of the inhabitants. It has to be efficient according to its metabolism. And it also has to be cohesive according to its social features. This means that we cannot only make a new city for one focus group. We have to mix them. It doesn't help us to have only for the lowest income one new city extension. There will be no buying force. There will be no commercial in the ground floor because people will have no possibility to maintain this. So mixture of a social mixture is very, very important also by taking into consideration these new city extensions. How can we control this? I mean, these are different factors, these are different aspects which are important in order to be sure that it will work. This can only be controlled if we can measure the different KPIs and if we can control them at the same time. So we have to control the functional KPIs at the same time than the ecological KPIs, at the same time that the social KPIs, and at the same time than the economical KPIs. Because we all know if these projects are not fitting into the budget, it's not feasible at the end. So what you can see on the slide I'm showing here, this is a project we had been done in Moscow. It's called the Spanish Quarter. It had been finalized in 2017, and we won the European Property Award for this project. And these are like the different images you see is like some of the KPIs. It's just a small selection, how they have been measured. There are points we measure like the corrected compactness. How compact is the different stages of the project? How many apartments on 1 hectare? What is the public space we can find? What is the difference of the public space? How can the different public space attract different activities? Where do the people meet? How we can bring people together in order to have a sense of neighborhood and community? The public transport coverage, important. It has to do with the connection, what I mentioned before. In order to make this work, you cannot make disconnected land developments with no connection to the surroundings. This connection can be public transport. This connection is also with the main roads. Infrastructure cost is an important point when we talk about new city extension. The diversity, how many different uses I can find in this development. If there is some offers for workplaces, if there are some offers for buying, if there is some offers of educational facilities. So all these different KPIs has to be measured and has to be balanced one between the other. So this is what we do with our system of this ecosystemic urbanism. We have multiple variables and they help us to model different scenarios. And these scenarios we can balance one against the other. And we can see by optimization of the KPI, which is the most optimum in terms of all the four different pillars. So it's not possible to fulfill everything 100% because some things are even contradictory. But like the big challenge is to find the best balance between all the four. And in this way, you can have, you can have a compensation between different factors, which maybe will not be able to fill 100% all of them. I will show you now a short video. This is taken on this Spanish Quarter I was saying before, where you can look a little bit how it is today, how people live together, how this is animated, and how we try to bring together these four different pillars I mentioned before. Okay, so this is a project in Russia, which is at the moment one of our main market, but we are also working in other countries like India. We have projects also in Africa. We did one project in Nairobi. In order to do so, we said that the challenge is that the world population will increase and will live in cities. So we have to face like two different types of challenges. One is the need of a sustainable development, which goes through the optimization of the KPIs and to simplify these complex mixed-use scenarios by working with standardized and a modular approach, which will help us to go away from the traditional way of constructing to offsite production, and in this way, industrial approach. This is like the new approach we would like to present, or we would like to defend. But how can we do this? I mean, this is only possible if we go for a digital transformation. It is not possible to control those issues in a traditional way of designing and managing the cities. So in order to be able to do so, we need a design platform and we need management tools. This is also why we had been investigating through the last years and how to develop a software which is able to bring all these factors together, to control, to balance, and to be able to adapt. Because what I said before is those planning, what we are doing, is normally not an issue of 5 years. It's an issue of 20, 25 years. City extensions are huge. The market is changing, the requirements are changing, and what we are doing today is needed to be adaptable to the future demands. So now I would like to show you a little bit about this program and this tool we are working with. This tool, we call it PSP. This calls Parametric Smart Planning. This Parametric Smart Planning is working on the different scales of the project. It works on the urban development, and it also works on the housing development. This means that we are working with standardized elements in the urban design, and we're working with standardized elements in the housing design. All the different scales are coming together in this one goal approach. Let's call it like this. So this tool is able to analyze, generate, optimize, and visualize those complex urban scenarios. It is able to consider the functional, environmental, and social KPIs as well as the economical ones. And it helps to industrialize the planning and construction process for massive affordable housing. What is massive? Massive is a minimum mass in order to be efficient to work with this approach. What is the minimum mass? The minimum mass is between, let's say, 1,000 till 3,000 and more, always possible, housing units. When we start to work from this number, then this approach is effective, is feasible, and is very efficient. Let's call it like this. And by taking under control all these issues, we are using a parametric and an algorithmic software. This one has been developed in-house. It's now under process to bring it on the market. All our projects, we are working with this software, because this helps us to be fastly able to give a very, very precise approach for the whole development. So we will not take months to do the master plan, or months to do the housing design, or months to know what will be the economical approach on this. It's a very, very fast tool, and it helps to control all the different levels of the project at the same time. So this tool is working in different stages, in different phases of the project. So the stage one, we have to control the existing site. This is a tool that is adaptable to where we work. As I said before, we have our main market at the moment is Russia, but we're also working in other countries. So it's very important that the tool adapts to the specific conditions of the surroundings and the site. This means that we will need to program and to let it know where we are working. Sun requirements is not the same if we are working in Moscow or if you're working in Nairobi. In Moscow, you're looking for the sun. You would like to have as much sun as possible. The more south you go, people are trying to hide. The same here in Spain. So geographical data is one of the main issues. This will also mean that this approach is global, but obviously it has to be adapted, and this is what we always do, to the special local conditions, not only on the climate, also on the culture. People don't use the same way to live together or share their time together on the different cultural level. So this is also something that is very important to take into consideration, and we always do by a very local research, let's say. Okay, so the first step when we work with this parametric smart planning is really important to have all the features of the site. This also means where are the connection points to the surrounding streets, where we have existing water courses, where are green areas we would like to take into consideration, if there is existing building you cannot demolish, etc. All these features which are important to take into consideration before starting, will need to be introduced in this program. Then the program is starting to prepare the structure master plan. The structure master plan means we will need to divide this whole unit, let's say, in different residential neighborhoods. Normally, what I say, our developments are between 100 up to 2,000 hectares. So we need residential units which are able to work independently. This is important because in one construction stage it's important to have all the needs which you really need to satisfy the day-by-day need. You cannot wait to have a kindergarten or a school in the next 15 years when the whole development will be finished. So we are working with these so-called super blocks. For us, one super block is one residential unit. This is between 500 to 1,500 units, where you have enough different uses in order to work as an independent unit and to satisfy the day-by-day needs by the inhabitants. So when you look at the point 3, what we call detailed master plan, you can already recognize which are like these super blocks. They all count with a public area for themselves, a public space, a little park, a neighborhood square or something. They all count with a minimum equipment of educational facilities, of social facilities. They all count with a minimum equipment of commercial. So this is like a unit which works independently. If you can see, this is like working like a hierarchical system, hierarchical or fractal system. We have like the connection points, we have like the main roads, which we call like the level number 1. Then inside the different units, we have like the distribution areas where you go to the neighborhood or to the housing itself. The same is working with the green areas. There is like a central park. Then you have, this works for the whole city or a central park, or let's call it an important green area. Maybe it's existing forest or whatever. And then on the next scale, what we call residential super blocks, then we have like these local squares, or we have these neighborhood squares to meet. And the same happens also with the facilities. There's like central facilities, which can be a hospital, but then you have the local facilities which are respecting like the different neighborhoods. So on the first point, we already introduced like the block typologies we are working with. This is now already related to edification, to buildings. And we can optimize then by testing the different KPIs. These KPIs depends, important KPI is the sun, important KPI is the compactness, important KPI is the distance for different uses like a school or a kindergarten. So by optimizing these different KPIs, then we get the optimization of the final master plan, where you can already see implemented the housing project. I will show you later a small video where you can see how this software works and how this step-by-step is going in order to have a first idea. If you go to the next slide, we can see these are like some screenshots from the program, which are the different KPIs we are measuring. It's just an example. It's very similar to the ones you saw before related to the Spanish Quarter. You can see that we have been working there with this program. So there is a map of distances. There is a sunlight analysis, a map of connectivity, of covering of the public facilities, of compactness, etc., etc. In total, we are more or less controlling between 50 and 75 different KPIs, important KPIs, by doing this kind of development. And we bring them together in order to balance. So normally the process is always running through different scenarios. So we will never get the first scenario, the optimum one by the first shot. But we can correct, we can give more importance to one aspect, another importance to another aspect, and we can see then how we can get out the best result for every specific project we are dealing with. So I will show you now a video, how this software is working. I will speak a little bit, and it's running fast. And I hope it's better for you to understand it by this way. Oh, there's one more slide, I forgot. Yeah, this is like the control panel, like how it's working. So you see that it's a graphic. You have the graphic of the master plan, but we're always working with a lot of data. The important issue is data. Data is the base for decision making. It's not about a nice layout. It's about efficiency and the feasibility of this project. So we have like here on the left-hand side, you can see the development stage we are working on, and at the moment on this master plan, then we have the dashboard buttons, then we have all the parameters we are controlling at this level of the master plan, let's say. Then we have for sure the geometry window, where we can see on real time how this affects like the layout of the master plan, and on the bottom we have the different KPIs. This is just a summary, but you will see now in the video how these KPIs will open, and how this is like a long list of different factors which are taken into consideration. So now I think we come to the video. Okay, this is a plot you saw there. This is a project we did in Hamburg, in Germany. Yes, first we have to introduce all the data from the site. This is related to what I said before. You can see that there is a green area, a river course running. Once we have this, that we have to work out a structure master plan. It's important to indicate the connection points. And as said before, the software is able to generate a block structure and a super block structure. At this stage, we are already controlling different KPIs. For example, the distance to the different facilities, that everything is related to the right green areas. And also at this stage already, we are able to control the infrastructure cost. We are able to control this at this moment. It's running fast, this video. Now you can see how we apply like the different building types which will be implemented. This is based on this modular approach. These buildings are all based on this modular standardization approach. This is a sunlight analysis in order to fulfill that the sun is controlled in every corner. This is and I told you there are always a lot of data which will need to be controlled, and output data you can ask the program in real time. You can export this to BIM, AutoCAD, and FIS. And this is one of these indicators you can see we are controlling. This is the compactness, and this then the balance. You are able to get a certificate of this. You are able to work with different densities of urban scenarios. Can work with high, medium, and low densities, depending also to the different sites. And this is the Spanish Quarter in Moscow, which took us from starting the design process at late 2013. The whole project was built in 2017 at the beginning. We're talking about 4,000 housing units, 2 public schools and kindergartens, a lot of commercial activities. And yes, this is this project I was showing before. Okay, so I will like to thank you for your time and your attention. And if you have any other questions, I will be ready to answer. So thank you very much.